Okay, so now we're going to do a couple problems involving trigonometric equations with multiple angles. Um, Again, the key to this is it's just like any other trigonometric equation. You're just going to have an additional step at the end to deal with the multiple angles. So this equation, you have 2 times the cosine of 3t minus 1 equals 0. So your first step is that you're going to solve for the cosine of 3t. Um, don't worry about the 3t until later. So our first step, we're going to add 1 to each side, and you're going to get 2 times the cosine of 3t equals 1. You're then going to divide by 2 to get to get cosine of 3t equaling 1/2. Um, Now at this point, we are trying to get t by itself, but before we can do that, we have to get 3t by itself. So because we're doing the cosine of 3t, we are going to leave 3t alone and do the inverse cosine here to find what our answer is going to be. So in this case, we look on the unit circle and we say, where's the cosine 1/2? Well, the cosine is going to be 1/2 in 2 places. At pi over 3 and also at 5 pi over 3. Now each of these we have to add 2 pi k to account for all of the coterminal angles that they could have. So this is the first step. Since they don't give us a range to answer in or a domain to answer in, we have to have this plus 2 pi k to account for our coterminal angles for these. Now that we have this answer, again, this is for 3t, not for anything else. So we need to solve for t. And it's as simple as just dividing by 3 on both sides. Now, the important thing here is that we're dividing this whole thing by 3, not just the angle, but the entire thing. So what we need to do is we're going to divide by 3. What you're going to get is you're going to get t equal, so pi over 3 plus 2 pi k over 3, and you're going to get 5 pi over 3 plus 2 pi k over 3. Now, you're going to want to simplify these. So for our top function, pi over 3 plus 2 pi k over 1, okay? That gives us pi plus 6 pi k over 3. So we can think of that as the same thing. So this is pi plus 6 pi k all over 3. And then because we are dividing this whole thing by 3, it's like multiplying by a third. So what we'll end up with is pi plus 6 pi k over 9. And we're going to do a similar operation for this. And so for this one, we're going to get 5 pi plus 6 pi k over 3. And so I'm going to change this answer. So this is 5 pi plus 6 pi k over 3. And when we divide these out, you're going to get this over 9 as well. And so we need to also say where k is an integer. So because we have this 3t here, our answer is going to be a little different. It's going to look strange because we've got 3 times as much going on. It changes the period of our function, so it's going to look different. We're not really necessarily, you don't see the 2 pi k anymore because our period's changed. But this is how you would go about finding the value of t that would satisfy this equation. So again, a similar problem. We start off and we say, we've got 3 times the tangent of x over 2 plus 3 equals 0. So again, we want to, first thing first is we want to solve for the tangent of x over 2. So we're going to subtract 3 from both sides, and you're going to get 3 tangent of x over 2 equals negative 3. We then divide by 3 on both sides, and we're going to get the tangent of x over 2 equals negative 1. So at this point, we need to free up our x over 2, so we need to find where on the circle is our tangent going to be negative 1. So remember, tangent has a period of pi, and so we're not going to have multiple answers here. We can just pick one answer, and then we add pi k to it. Simple as that. So we're going to know that the tangent is negative 1. First place where that occurs is going to be at, we can call it multiple places, but if you did the inverse tangent here, you would get negative pi over 4, and then plus pi k. So this is the same, so negative pi over 4, 3 pi over 4, 7 pi over 4, and all these other angles, all of them have a tangent value of negative 1. So now we need to finally go back and we need to solve for x, because that's what we're looking for. So in this case, x is going to be each of these multiplied by 2. So if we multiply all of this by 2, we're going to get our correct answer. So 2 times x over 2 gives us x. And 2 times this, we're going to get negative pi over 2, because negative pi over 4 times 2 gives us negative pi over 2. And we're going to add 2 pi k to it, because 2 times pi k gives us 2 pi k. So you may say, well, that looks different. Why? That's like sine and cosine. Well, the period of tangent is pi k. And in what we've really done by doing x over 2 is we have kind of stretched out from side to side what our tangent function is going to look like. So for x over 2, the period now is going to be larger. It's going to be 2 pi. So adding the 2 pi k makes complete sense here. So this is our answer to our problem. You just got to make sure you know the periods for sine, cosine, and tangent. And if you know those, then when you add them on, do the simple math, you'll get your correct answer.